Hello guys, today we are going to discuss a thevenin theorem upon this circuit. So here in this circuit we got two voltage sources, E1 and E2. E1 and E2. So for this we are going to apply a superposition theorem. For our convenience. So here in this circuit we got three resistance, R1, R2, R3 and R4, and one is RL resistance, which is a load resistance. So for thevenin theorem, first step is to remove that load resistance. For temporary basis. Now we will convert this whole circuit into a circuit which consists of ETH, thevenin voltage and RTH. ETH and RTH. So for this we are going to apply some steps. When we are going to find RTH, first we are going to eliminate E1 and E2 and replace this E1 and E2 by a short circuit. So first step is to remove E1 and E2. Our circuit will look like this. Now when we look into the circuit from this side, so here in this circuit R1 is actually parallel to R2 and parallel to R3. So these three resistors are actually in series with R4. Let's find RTH. So RTH is actually equal to R4 plus R1 parallel to R2 and parallel to R3. So RTH is equal to R4 is 1.4K and R1 is 0.8K parallel to 4K. So when we solve this, all of these, so it's equal to 0.6K. When we add this, which is equal to 2K, so we found that RTH is actually equal to 2K. Now in second step we are going to find ETH. For ETH we will return the voltage source and we will also apply a superposition theorem here in this circuit. So our circuit will look like this. So we return E2 and we will find ETH. we will find ETH dash. So for circuit 1, now when we return the E2 here, so ETH is actually across a resistance R3. So ETH is actually equal to V3. Now, so there is no current here in resistance R4. So the voltage, so we do not consider here this resistance. We do not consider this resistance because the current flow here in this resistance is 0. Now what we are going to do here in this circuit, we have a situation here. So here in this case R1 and R3 are actually parallel to each other. So RT dash will equal to R1 parallel to R3, and this RTH is actually in series with R2. So when we calculate this, is actually equal to 0.706 kilo ohm. Now for ETH we are going to apply a voltage divider rule. So the voltage will divide among RTH and R2. So the voltage will divide among these two. So RTH with a potential E2 and RTH dash plus R2. So when we calculate all these, which is equal to 7.06, 4.706. Now so ETH dash is actually equal to 1.5 volt. now so we will eliminate E2 and return E1. So in the second case, for finding ETH double dash, so for ETH double dash we will return the another voltage source. So our circuit will look like this. Now so we will find ETH double dash. Now for ETH double dash is actually equal to V3. So R2 and R3 are actually parallel to each other here in this case. So RTH double dash is actually equal to R2 and R3. So this RTH double dash is actually in series with R1. Now R2H is 4K parallel to 6K, which is equal to 2.4K. Now so RT double dash is actually passed in series with R1. Now we will apply a voltage divider rule to find ETH double dash. So which is equal to RT double dash E1 RT double dash plus R1. When we solve all this equation, so is actually equal to 14.4, 3.2. When we divide this, is actually equal to 4.4 volt. Now what is ETH? So ETH is actually equal to ETH dash plus ETH double dash, but these both voltage sources are in opposite polarities, got opposite polarities. So ETH will actually equal to 4.5, which is ETH double dash, minus 1.5, which is ETH dash. So we got that ETH is actually equal to 3 volt. Now we found two components of thevenin equivalent circuit. So thevenin equivalent circuit will look like now thevenin equivalent circuit will look like this. Now when we got RL, which is load resistance, for example, when we have a load resistance equal to 2K, so what will happen? Which amount of current will flow across this resistance? So what is IL current? So for IL current we can simply apply Ohm law. So we can simply imply Ohm law. For example, IL is actually equal to ETH, which is 3 volt, and RTH plus RL. So 3 divided by RTH is 2K and RL is also 2K, which is equal to 4K. Now when we simplify this equation, IL is actually equal to 0.75 multiplied 10 raised to the power minus 3. So we can easily find IL current, and we can change whenever the voltage, whenever the load resistance is changed. Thank you for watching. This is the end of the lecture.